right, so today we're going to be talking about changing the base on a logarithm. Most of the time when you see this log something that is set up to imply that we are talking about log base 10. So what this equates to, we remember from previous times, is 10 to the second power equals something, in this case x, or if it's written like this one here, the second one, we have 10 because there's nothing there, so it's implied that it's log base 10 to the something power equals whatever our number is. However, there are some times when you don't want to deal with log base 10, and modern technology allows us to just go into Desmos or go into our calculator and just change our base. But that wasn't always the case. So what we want to do now is figure out how to use these logarithm tables, which is what people had for a very long time. I'm not exactly sure when technology caught up to the math to be able to just, type in, push a button, and all of a sudden you're looking at log base 5. But we're going to learn how to use the logarithm tables to be able to change our base. So if we were just thinking about this, thinking about how logarithms work, if we were to look for, say, the logarithm in base 5 of 25, we should then, right, going along with this second one, we should get 5 to the something equals 25. So that something should be squared, right? 5 squared equals 25. That's what we're looking for. This x should be a 2. Okay? So again, we're using the logarithm tables that we already have, which are in base 10, to find logarithms of different bases. All right, so what we're going to do, since we have logarithms in base 10, we are going to take the log of the number, the answer, in this case our 25, and divide it by the log of our new base, so log 5. Now, if you type this into your computer or into your calculator, it's going to spit out a 2 for you, which is all great and wonderful as long as you put all the parentheses in the right place. We're not going to look at that right now. What we're going to do is use the logarithm tables because, historically that's what people had. So we need to look up our logarithm of 25. So we go to our logarithm tables and don't turn the page. Okay, so here's our logarithms. We come down, we're looking for 25. We've got zeros here. That means there's nothing in that column. So any of these numbers, it's going to be 0 point decimal place. Okay, so we're going down. And now we get to 10 and we see these zeros. That means we've now switched our unit. And so we would then be at 1. Okay, because 10 to the 1 is 10, right? So the logarithm of 10 would be 1. There you go. So now any of these numbers above here, it's going to be 1 point whatever. So we keep going, looking for 25. We haven't gotten to another set of zeros, so it's not going to be 2. So we know that our logarithm is going to be 1.3979. So we come over here, equals 1.3979. There's our logarithm of 25. Now we need to find our logarithm of 5. This is the button I want. So we find our 5. It's 0.6990. We know that because we only had those 0, right? We know that there's a 0 there because we haven't gotten up to 10. Okay, so we have then 0.6990. Again, I got that from our logarithm table. And then just to make sure I'm not cheating or magic or anything like that, we're going to go ahead and put this into a calculator. Now, these are rounded to 4 digits, so it might be off a little bit with rounding. But again, we're looking for something that's going to be very close to 2 because we know that 5 squared is 25. We want something that's very close to 2. Move, please. Okay, so 1.3979 divided by 0.6990 and 1.9998. For my money, that's pretty close to 2. Okay, so there you go. Some nice proof that it works. So this is roughly equivalent to 2. It was what, 1/10,000th off? I say it's pretty close. Okay, so if we want to look at that again, let's say we want to change to log, let's say base 2, and we want to get 8. So in our minds, we know that that should be a 3. We're going to take log base 10 of 8 divided by log base 10 of 2. And again, when we divide that out, we should get 3. So let's look up our log base 8, our log of 8. Log of 8 is 0.9031. Log of 2 is 0.3010. 0.3010. We do, oh, I got rid of my calculator. I always do that. Okay, so 0.9031 divided by 0.3010. Again, leaving a little room for rounding, but that's pretty close. Approximately 3. Again, with a little room for rounding. So if we're trying to change base, we're going to take log base 10, which you find on your chart, of our answer, divided by log base 10 of the new base. And that is how you get log base 2 of 8 equals 3, without just typing that into Desmos. Again, this was developed for a time when all mathematicians were the logarithm tables, and those were figured in base 10. So if you needed a different base, you needed to do this. All right, so hopefully this is making sense. If not, go ahead and email me, and otherwise I will talk to you with a live chat.